Yes, Mr. Anthony.
Yes. You can hear me?
How come Mr. Dairu is unable to log in?
Yeah, that's what I'm also wondering. And also, we also have very few students. It's as if there was no good communication. These are only 20. They're supposed to be over.
They were using this link, but I already sent the message to Moffat to follow up.
Yes.
So that now he's able to marshal the others to use the new link.
Yes. So I
But they
think
can hear us.
you are the host now.
So I do the admission only.
Yes, you can do that. Yeah, you can do the admission. You are the host. Okay. Yeah. So let me talk
then
to Mr.
we wait
Yeah, let me talk
to
to
Mr.
Moffat.
Dairo.
Yeah.
Okay, sir.
Okay.
Good morning, students. Good morning. Good morning, students. Good morning.
Morning, sir.
Good morning. Can you hear?
Morning, we can hear.
Good morning.
Morning.
Oh, thank you.
Good morning.
I'm sorry we had some is why we wanted to start on time. And proceed. Today, physics shall go through a KCSE paper so that you can try to recap on some of the areas that you have already shall go through a KCSE 20. As we move on, I think we can proceed. Can you proceed? Can you hear me?
Yes, we can.
Oh, sorry. We're experiencing some network connectivity problem. That's why it is pausing. Okay. Then we can start. Gauge has a negative 0.03 millimeter error. Set the reading that is observed on the instrument when used to measure the diameter of a wire. Actual diameter is 0.38 millimeters. Now, we can ask ourselves, when we have a negative error, what do you normally do to take care of a negative error? So, Josiah Mwenda, negative error, how do you handle it?
We add. We add.
We add.
Yeah.
Therefore, in this case, for this error, we are going to add. Now, because we have the actual data, we don't know the reading. We say that it's going to be, so we are going to add 0.3. So the moment you add 0.3, then it is supposed to give us the actual reading, which is going to be 0.38. So that will be the reading. Therefore, our x becomes what? Khalid, work it out. Give us the value of x. Khalid.
0.35.
Pardon, Khalid?
0.35.
0.35. Our answer in this case is 0.35 millimeters. So, pardon? So, can we proceed?
Yes.
For you to start with from this. That's true. Explain this observation. It is good for you to note that in this screw there is a hole. So the moment you start, this hole has some effect. Those who are writing the ground, writing, please stop sharing so that you can have one common background. So the question is asking, why is it not possible? So Collins Mwema attempt the Collins Mwema. Collins Moffat come out. Moffat Bran Kimutai. Bran Kimutai. I think there are some students in those areas.
Sure.
They cannot be able, we cannot see them. Yasin Mohammed. Yasin. Alan Cheruyot. Brent. Brenda Ness. Students are Hello, students, can you hear me? Hello.
Yes.
Can the students hear whatever I'm saying?
Yes,
Mr.
we can hear
can
you.
hear you.
Yes.
Students, can you hear whatever I'm saying?
Yes.
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 Okay. Then let us proceed.
Yes.
We were in this question number 3. 2 ways of reducing surface tension of a liquid. 1, Collins Mwangi. Give us one.
Increase in temperature.
Increase in temperature, correct. So increase in temperature, some students may decide to use the word heating the liquid, which is okay, or raising the temperature. Second way, Wesley Wawero. Wesley Wawero. Wesley Wawire. Wawire, give us the second way.
Well, I'm saying.
Pardon? Wawire, give us the second way.
Adding impurities.
Heating, we have talked about it, heating the liquids.
Adding impurities.
So, adding of impurity, correct. So those are the 2 ways in which we can reduce the surface tension. Let's go to the next question. Figure 2 shows a round bottom flask containing a colored liquid. The flask is fitted with a capillary tube, as we can be able to see. This capillary tube is observed that on holding the flask with bare hands, the sides of this flask with bare hands, the level of the liquid in the capillary tube initially drops slightly and then rises. Explain this observation. 3 marks. So let's have some attempts from different students. So Alex Apollo, explain this observation for us. Apollo, we are waiting for you. Eddie Carrenjo.
Yes.
Eddie.
When you touch the flask with your hands, the round bottom flask expands fast, making the level of the liquid to drop. Then the colored liquid expands faster, hence it rises.
That is it. So the first mark is to show that the flask expands fast. The word fast ought to be there. This increases the volume. So second mark is showing that there is increase in the volume of the flask. So the level is going to drop. Then the other mark is to show that the liquid then expands more or faster than the flask. So that's how we can work on such kind of a question. We now move to question number 5. Figure 3 shows 2 metal rods A and B of equal length made of the same material but different diameters. Wax is attached at one end of each rod. A source of heat is placed between 2 metal rods. We can be able to see rod A and rod B. This one is thinner than this one, but they have the same length, and also they are made of the same material according to the illustration. State with the reason what is observed on the wax. What do you think is going to be observed? Owiti? 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 Victor Mwiti, can you hear me? Victor? Victor? Maurice Rodgers?
The wax on B will fall. The wax on B falls fast before A.
That is the first mark. Reason?
This is because B has a larger cross-sectional area than A, thus it will get hit first.
Through which mode? The mode of heat, we must talk about it.
By convection.
No, not convection. It is conduction. So
Oh
the
yeah, by
first mark you got
conduction.
it when you say, yeah. So the first mark you got it by stating that the wax is going to melt first. Then second mark is to show that B, with a bigger cross-sectional area, it conducts heat faster. Then we move on to the next question. On the axis provided, sketch a displacement time graph for a trolley moving down a frictionless inclined plane till it reaches the end of the incline. Till it reaches the end of the incline. Now, the first thing that we need to notice is that the trolley is moving down. When it is moving down, which force is acting on it? Jiro Nyaga? Which force is acting on this trolley that is moving downwards?
Gravity.
Gravitational force. Therefore, if it is moving downwards because of gravitational acceleration, then we expect it to be accelerating as it is moving downwards. But now here we have been frictionless inclined plane. So if it is frictionless, then it means that it is moving without experiencing any friction. So there is continuous acceleration. Therefore, displacement type graph is going to move like that to show that there is an acceleration. So for example, here, if you look at it, if I'm to draw both read-off lines, you note that a smaller displacement taking longer time, meaning that the body here was moving slowly. But if you have to do the same effect, if I have another read-off like that, note that this displacement here, same case to this displacement, the displacement here is covered within a very short time, meaning that the body at this position, it is moving at a higher speed as compared to this one. This one was taking more time. So in that case, it means that the body is accelerating. So that is the nature of the graph that was expected in the exam. Then we move on to the next question. So the next question 7, a student carrying heavy box using the right hand is observed to lean towards the left hand side. Explain this observation. So why do you think that student is going to lean towards that direction? So Alvin Kingo. Alvin, you can answer us. Alvin. 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 Now for those students, if you are going to use funny pictures and the names that are not your real names, I'm sorry, I will be removing you from the group so that we only deal with serious students. So Franklin Irongo, why do you think this student is going to lean on the left-hand side? Franklin Irongo. Franklin Irongo. Gulam. Gulam. Franklin Irongo.
This is because carrying a heavy box using the right hand means that increasing the weight and increasing the moment on the right side. Therefore, as the student is supposed to lean towards the left-hand side to balance the moments so as to maintain stability.
That is it. So the first mark is to show that once the student is going to carry heavy box in the right hand, position of the center of gravity will shift towards the right. So the position of the center of gravity shifts towards the right. So that one is going to have imbalanced moments. For it now, for this moment now, for the balancing effect to take place, then it means that the student has to shift to lean towards the left, to shift the C or G towards the left in order to balance. So second mark is shifting C or G towards the left in order to balance or in order to obtain the equilibrium. We now go to question number 8. Figure 4 shows 1 meter long uniform rod of negligible weight supporting 2 weights. Determine the position of the fulcrum from 0 centimeters for the rod to remain in equilibrium. So we don't have the pivot in this case. Suppose you place the pivot at that point. So determine the position of this fulcrum or this pivot from 0. Therefore, I give 1 minute to do the calculation and then you give me the answer. Work out in the calculation. Once you're through, you tell me. I'm waiting for you. Anyone withdraw? Anyone withdraw? Anyone withdraw? What answer are you getting? What answer are you getting? Don Masibai. Are you through? Don?
Not yet.
Oh, okay. Gareth Dumia, have you gotten? Gareth? Gareth Dumia?
Not yet.
Okay. Enoch Suva, have you gotten?
Not yet.
Okay. Somebody with the name Ken. Ken, I don't have your 2 names. Ken, I don't have your second name. You'll be forced not to leave the meeting. Brian Murezi or Ingwe, you have gotten? Brian Ingwe, what answer are you getting?
50 centimeters. 25 centimeters.
50 centimeters. Are there other students getting 50 centimeters?
Yes.
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 Okay.
Yes.
Let's see how we can work it out.
Yes.
Suppose now this length from the pivot here, we label it as X. And we can be able to see that the length from here, 5 centimeters up to 80 centimeter mark, that difference is 75 centimeters. Then it implies that this length is going to be 75 minus X. So that is going to be our length. So in this case, we know to get the first mark is when you are going to write in full that clockwise moment is equals to the anti-clockwise moment, and you must write in full. I'm only writing like this to save on time. So this being the case, then you have to take all the clockwise moments, which is going to be 15 newtons times the whole of this. So we have 15 multiply by the length from the pivot, which is 75, minus x is equal to the anti-clockwise moment, which you can see it is 10 times x. 10 multiplied by x. Open brackets here. So we have 15 multiplied by 75. What do you get? 15 you're multiplying by 75. It is 1125. So this is going to give us 1125 minus, we have 15 times x, which is going to give us 15x. The whole of it is equals to 10x. If you work it out, take this to the other side and it becomes plus. Therefore, this side you are left with 15, 25 being equal to 25x, because it is going to add 15x plus 10x. So divide every side by 25, and finally your x becomes 45 centimeters. So if our x is 45 centimeters, we are not through. Remember, the question is asking us, determine the position of the fulcrum from 0 centimeter. So this x is the one that is 45 centimeters. So we have to add 5. Therefore, it means that the value becomes 50 centimeters. So that becomes our final answer. We now move to the next. So in our next question, we're going to keep this on your number 10. For a fluid flowing at a velocity v in a area A, V is equal to constant. Set two assumptions made in deriving this equation. Two assumptions that are going to be made. Let's have a volunteer to give us one assumption. One assumption that is made. Ryan. Benjamin Mwania. One assumption. Maurice Rodgers, yes, you are lifting your hand.
The flow is streamlined. The fluid is streamlined.
The fluid flow is, yeah, the fluid flow is streamlined. That is one.
And also
the other assumption?
The fluid is non-viscous.
The fluid is non-viscous. The fluid is non-viscous. That is the other one. Another person, Alex Apollo. Alex Apollo. Alex. Maurice Rodgers, you have another one?
No.
There is another one that you are living. Ronald. Yes, I wonder. Julius Mokio. Julius.
The fluid is incompressible. The fluid is
The fluid compressible. That is it. The fluid is incompressible. So any of the two those three is correct answer. Number 11, we are going to skip it. We have not covered it. Let's go to question number. Five shows spring C and D of the same length and equal number of arms made from the same wire. State the reason which of the two springs support a heavier load before attaining the elastic limit. Between the spring C and D, I want you to note in terms of the diameter of the coil. So find that C has a smaller diameter as compared to D. So which one do you think is going to support a heavier load? So let's have a vote here. Agustin Kaguma, which one do you think is going to support a heavier load? Agustin? Agustin? Agustin, we are waiting for you. Agustin? Bruce Gedaiga? Between C and D, which one is going to support a heavier load? Bruce Gedaiga? Bradley Chabaga? Bradley Chabaga? Bradley Chabaga? Okay, someone to lift the hands. Let's have someone to attempt.
Spring C, because that's a lower diameter, that's reducing the distance.
So you have there, yeah, it is C. So C, it has a smaller diameter, therefore it is going to support heavier load because it has a higher spring constant. C has a higher spring constant. It has a higher spring constant. So we can move this. Two boxes E and F of masses 0 kg, 4.0 kg respectively are dragged along a frictionless surface using identical forces. State the reason which box moves with a higher velocity. Which one do you think is going to move with a higher velocity? We have 1 2 kg and F of 4 kg. What do you think is going to move at a higher velocity? Let's have a volunteer. Carlos Kibagendi. Carlos Kibagendi. Brian Murege. Brian Murege. Come on, where are the students? I cannot get you. Zach Kege. Zach, can you hear me? Zach.
I think.
Yasin Mohammed. Okay, Zach, you can answer us.
The box.
Which box is going to move?
The box with a mass of 2 kgs. 2 kgs.
2 kgs, that is correct. What is the reason?
This is because it requires less force to lift the box off the ground, although there is less, which means there will be less friction.
But note here that they have identical force. They have identical force. You are pushing them with identical force. Now let me just give you the answer in this. We are using Newton's second law of motion. Newton's second law of motion formula is equals F is equals to what? F is equals to M? A. Now, because here we can be able to see that it is identical force. Suppose we just give it a number. Let's say the force is 20 newtons. We now deal with a mass of 2 kg. If I put a mass of 2 kg here, then it means that our acceleration in this case is going to be 10. So that is going to be acceleration. Repeating the same formula, F is equals to MA. Then this implies that the same force of 20. Now we use the mass of 4 and we see the answer that you're going to have. Therefore, this is 4A. So this means that our A is equals to 5. I'd like you to compare the two answers. When the mass is 2 kg, acceleration is 10. When the mass is 4, acceleration is 5. This one that is accelerating and at 10, then you expect it to move at a higher velocity. Therefore, the basic concept which was hidden in this question was for you to apply Newton's second law of motion formula. Then we move to question number 14. In our question number 14, a student is provided with 5 20-gram masses, a meter rule, a spring with a pointer, a stand, a boss, and a clamp. In the space provided, sketch a labeled diagram of the setup that may be used in order to verify Hooke's law using this apparatus. It is important for you to note that the question is talking about a labeled diagram. You have to use a labeled diagram. This one you have done, you've used several times in the lab. So you have a stand. So this is going to be our stand. So because you've been told to label, it is good for you to label. So here we have a stand. So it has a clamp and boss here. Then there is a spring. This spring is supporting a mass. Then on the side, you will have a rule. The rule is the one that will be reading the extension. So it's going to be our rule, the extension. The spring on the lower side, it needs to have a pointer. So you have to label everything. For example, this one, you label it as a spring. You label this one as a rule. You label this one as the mass. This one as the boss and the clamp at this end. So all that is what was required in that question for you to be awarded the marks. Then you can be able to move to the next question. Benjamin Mwangi, stop marking. So state 2 measurements that should be recorded in order to plot a suitable graph so as to verify Hooke's law. 2 measurements that should be recorded. Benjamin, delete whatever you have marked. Benjamin Mwangi, delete this tick that you are marking so that you can move on. Okay, thank you for your obedience. So state 2 measurements that should be recorded in order to plot a suitable graph so as to verify Hooke's law. So 2 measurements. Warren Chege, one of the measurements. Warren Chege, give us 1 measurement.
Extension.
Warren Chege.
Extension.
Extension is 1. Boya Ngala. Ngala. The other measurements.
Boss.
Ngala. William Mwadime. The other measurements.
Force.
We have extension. William Mwadime. The other one.
Force.
William, I'm waiting an answer from you.
Force.
Oh, correct. So 2 measurements. Now, Roman 3, the question is asking, describe how the measurements above in Roman 2 can be used to determine the spring constants. So once you get different measurements, you have to sketch a graph of force against extension. And this graph will give you a straight line as long as the elastic limit is not reached. Then from there, you have to show, remember the question is asking how we can determine the spring constant. Two ways. We can state that the slope will give us the spring constant. So the slope will give us the spring constant. So in this case, this is one way. The other one, there are some students who are going to state that the spring constant K is equals to change in force over change in extension. So those are two ways, and you get your 2 marks. Then we can move to the next question. A helical spring stretches by 0.6 centimeters when supporting a weight of 40 grams. Determine the extension where the same spring supports a weight of 65 grams. Let me give you 1 minute, quickly do the calculation, and then you give me the answer. Work out on the question. Work out on that question B. Anyone who is through? Ingwe? Run Ingwe?
0.975 centimeters.
0.975 centimeters. Do you have some other students who are getting the same answer?
Yes.
0.975 centimeters. Do you have some other students?
Yes.
Yes.
Do you have more students?
No.
Okay, let's go through it then. So the formula F is equal to K. From F is equal to K. Force in this case, the weight of 40 grams, the mass 40 grams,
Yes.
then the weight of the force becomes 0.4. So 0.4 is equal to the spring constant that we'd like to get first, multiplied by the extension force in this case is 0.6. So that is our extension. So having this one, it implies that K becomes 0.4 over 0.6, which is the same as 2 over 3. That is the spring constant. It is not a must for you to write the units at this stage. Now we are applying the same formula, F is equal to K. So the new mass is 65 grams. So the weight in this case becomes 0.65 newtons. So 0.65 comes the spring constant 2 over 3 multiplied by the new extension that we'd like to get. Multiply everything by the reciprocal of 2 over 3. And finally, your answer for the extension, we are going to have 0.975. Correct. So that becomes our final answer. Then we can move to the next question. Figure 6 shows a bottle top opener being used to open a bottle. Indicate on the diagram the direction of the load and the effort. So the direction of the load and the effort. So the opener at this position, that is where you are going to apply your effort. So your effort will move towards that direction. So this is our effort. Whenever you're indicating forces, make sure that you label. For example, labeling E for effort is okay. Then remember the condition that I told you when you're sketching the forces, it must be drawn using a straight rule. The load to be overcome, it is at this position, the opener, and it will be acting in opposite direction. So this is going to be the load. So that is the only thing that you are supposed to do, and you have to get 2 marks for each. I mean, 1 mark for each. So in total, you have 2 marks. Then we can move to question B. State 2 ways in which an inclined plane can be made to reduce the effort in pulling a load along the plane. 2 ways. 2 ways. So Alex, Apollo, 1 way of reducing the applied efforts. Alex. Yasin Mohammed.
Making the slope
Yasin?
more gradual. Making the slope more gradual.
How do you make it more gradual?
By increasing the angle of inclination. By reducing the angle of inclination.
By decreasing, that is it. Reducing the angle of inclination. By reducing the angle of inclination. The second way. Second way. Tony Calvins. Tony Calvins, give us the second way. Tony Calvins. Somo Buracha, give us the second way. Second way of reducing the applied efforts on an inclined plane. Can you have a volunteer? Someone to raise his hand. Rafael Musioka. Reginald Mobe. Someone to attempt. Misha Kibe. Misha Kibe. Lee Kamau. You don't have anyone to raise his hand so that you can be able to move on? Collins Mwangi. Collins Mwangi.
Reducing friction.
Reducing friction, correct. Reducing friction, it can be stated in different ways. There are some students who are going to state by lubricating, which is okay, by oiling the surface, which is still okay. Others, they are going to state by use of rollers, that is okay. So all those ways they are in order to reduce the friction. We can now move to question C. A block and tackle system has 3 pulleys in the upper fixed block and 2 pulleys in the lower movable block. Draw a diagram to show how the system can be set up in order to lift a load and indicate the position of the load and the effort. Remember, I told you for a pulley system to be said to be complete, it must have the point of support, the load, and the effort. So we can start with the point of support. So this is going to be my point of support. We are told that it has 3 pulleys in the upper fixed block. Let's have 3 pulleys. So this is the upper block. So that is my upper block. It has 3 pulleys in this case. Then the lower block has 2 pulleys. So this is the lower block now. With 2 pulleys. I made a mistake here. And of course, we need to have a load. These are load. Effort, let it be applied from that end. So this string for the effort goes around the upper pulley all the way. The lower pulley goes around, moves up. The second top goes around it, downwards to the lower second, goes around it, moves to the last pulley, and then goes around it. This end is attached there. So that is what was required in the question. And you get the 3 marks. Then state the velocity ratio of the setup. So Mwangi Peter, what is the velocity ratio? Velocities. What is the velocity ratio?
5.
Velocities. 5, correct. The number of strings supporting the load, that is 1, 2, 3, 4, 5. So velocity ratio is 5. We now move to the next question. In such a block and tackle system, an effort of 200 newtons is required to lift a load of 600 newtons. Determine its efficiency. So quickly do the calculation and then you give me the answer. Do the calculation, I'll wait for you. Anyone who is through? Anyone who is through?
Efficiency is 60%.
Efficiency is 60%. That is our answer. So this is how we can work it out. We know efficiency is equals to mechanical advantage over velocity ratio times 100%. This symbol, it has to be there if you expect that formula to be our data mark. You must have the percentage symbol. So then the next thing that we can do, we take our efficiency. First of all, let's work on mechanical advantage. We know mechanical advantage is equals to load over effort. The load in this case, according to the question, is 600 newtons. Therefore, we write down 600 newtons divides by effort of 200. Effort of 200. And this is going to give us an answer of 3. Therefore, it means that our efficiency here is equals to mechanical advantage that we've gotten as 3, divided by velocity ratio that we got previously, then multiply by 100%. So once we work it out, this one is going to give us 16%. So again, don't forget this symbol, and you get your 3 marks. So let me check whether you have another question that you can attempt, the one of your level. So we have question number 17. State what is meant by Brownian motion. What is Brownian motion? Rafael Musioka. Brownian motion. What is it? Brownian motion.
It is the
Come out. Okay, move on.
it is the constant yes, it is the constant random motion of particles caused by uneven bombardment between individual particles.
You are right. It is the random movement of particles. Random movement of particles of matter. That one is enough. Random movement of particles of matter. We can go to question B. Figure 8 shows a graph of velocity against time for a small steel ball falling in a viscous liquid. Describe the motion of the steel ball as represented by part OA. Part OA. To describe the motion of the steel ball. What can we say? Yes, Mark Davis Maranga. Describe the motion between O and A. What can you say?
Pardon?
Maranga?
Yes.
Pardon?
Yes.
Describe the motion of the particle between O and A. Describe the motion. Luis Chege, describe the motion.
It is decelerating unevenly.
Unfortunately, this one is not decelerating because you can see the velocity, it was 0, now it is increasing. Now, when it is curving like this, what can we say? Roy Wanderi, you have an idea? Roy Wanderi. Roy Wanderi.
Yes.
What do you think is happening between O and A?
It's gradually increasing in velocity.
There is increase in velocity, but now the curving is moving, lowering the gradients before attaining this velocity. So in short, let me just give you the answer. There is a decreasing acceleration here. I'm not saying it is decelerating. Remember, it was accelerating, but the rate of acceleration here is reducing. So we can say the body is moving with a decreasing acceleration. Now we move to the next. Explain why the velocity between A and B is constant. Why do you think the velocity between A and B is constant? Remember here we have said that there is a decrease in acceleration until it attains a constant velocity. Why do you think the velocity here is going to be constant? Yes, Leonard Karaoke. Leonard, can you hear us? Ian Mwao. Ian Mwao.
The acceleration is constant.
No, when it is moving at a constant velocity, the acceleration is 0. The acceleration is going to be 0. John Rono. John Rono. Let me give you the explanation for this one. Remember, according to our question, we are told it is a steel ball falling in a viscous liquid. Suppose this is the container. We have a liquid that is already inside. This is the liquid that is inside. Then you take a steel ball, you drop it so that it can start to move downwards. Initially, it will accelerate due to gravitational force. Remember, it has its own weight that is acting on it. But as it is getting deeper into the liquids, there is upthrust force that is acting on it upwards. This is upthrust, plus the viscous force that is still working on it. So this viscous force. When it is accelerating at this position, this weight is greater than the sum of this one. That is, weight W is greater than frictional force and upthrust force. But to reach us to a point, let's say around this position, whereby it attains what we refer as terminal velocity. At terminal velocity, the downward force will balance with the upward force. This is the point whereby it has now attained the terminal velocity. So our terminal velocity on the graph is going to be at that point. So in this case, the weight downward will balance or will be equal to the sum of the weights that are acting upward, which is F plus U. So at this position now, the net force acting in the body is going to be 0. Now the question is asking us, explain why the velocity between A and B is constant. So velocity between A and B is constant because downward forces will be equal to upward force. Hence, terminal velocity is changed. Therefore, resultant force acting is 0. The resultant force acting is 0. Now, we can move to the next question, which is going to be our last. Question C. A student throws a tennis ball vertically upwards from the ground and it lands back after 8 seconds. Determine the maximum height reached by the ball. So quickly do the calculation. Do the calculation. Once you are through, you tell me. Who is through? Who is through? What answer are you getting?
Iko. Mkate.
Pardon?
Pia kuna chakula.
John Segera, what answer are you getting? Joseph Ropongo, are you through?
Mwalimu sijaelewa.
Question C. Leonard Karaoke. Leonard Karaoke. Okay, let's go through the question. A student throws a tennis ball vertically upwards from the ground and it lands back after 8 seconds. So if you throw a tennis ball up and then lands, it takes a total of 8 seconds. Then it means to move up to the top, it is going to take a time of 4 seconds. You simply divide these 8 seconds into 2 and you get time of 4. When you throw an object upwards, it is going to experience an acceleration of -10, simply because it is moving the direction which is opposing gravitational acceleration. At the top, the maximum velocity, at the maximum height, then we don't know this maximum height S. But the final velocity at the top, which is going to be V, will be equal to 0. So we don't have a formula that connects all this if we don't have U, which is the initial velocity. So I would rather we first go through this Roman 2 together so that you can be able to get the initial velocity. We know V is equals to U plus AT. Why am I working with velocity with which the ball hits the ground? The velocity that you're going to throw this ball will be the same as the velocity it is going to land with. And this is the initial velocity. So V is 0 is equals to U, that we don't know, plus A, which is -10, multiplied by T, which is 4. So we multiply this one by 4. This is -10 times 4, which is -40. Take it to the other side, then it implies that our U is equals to 40 meters per second. So having gotten this one, Roman 2, we now take this 40 meters per second, substitute it here, and then it is good. We work out. We can now work with the formula V squared is equals to U squared plus 2AS. V squared is 0 squared. 0 squared is equals to U squared. Already we had 40. 40 squared plus 2A is -10, then multiplied by S that we need to get. So 0, first of all, this is -20S. Take it to the other side, becomes positive 20S. So 20S is equals, this side I have 40 squared, which now becomes 1,600. So divide every side by 20, and our S finally becomes 80 meters. So this becomes our final answer for that question. We now move on to the next. So from this paper that was done KCC last year, question 18 we have not covered. It is under gas laws. So which was our last question. Therefore, that is the far that you can be able to cover for today. So I will still insist that you keep on revising for you to prepare yourself. Despite whatever we are facing as a nation, learning has to continue. So I just want to encourage you to keep on learning, do not rest, and finally you will rejoice when you get the good results. So have a nice time. God bless you.
You too.
Thank you.
Thank you.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you.
Thank you.
Thank you.